Most of the time, tensioners are used in sets to have uniform compression of joints for proper sealing. General practice is to use 25%, 50% or 100% bolt tensioning. The recommended is 100% tensioning, which means that all bolts in the flange will be tightened simultaneously, achieving uniform compression using just one pressurization of the tensioners, followed by a check pass. However, all flange designs and geometry does not allow to use 100% tensioners. 50% tensioning means we use 50% tensioners to bolt ratio. Every alternate bolt will have tensioners and would need to be tightened in two stages. First stage with pressure A and second stage with pressure B. Bolts are marked as 1 and 2 and pressure A is applied on bolts marked 1 and pressure B on bolts marked 2. Pressure A will always be higher than pressure B to compensate the bolt load loss that happens when a bolt is tensioned next to an already tensioned bolt. This cross-loading bolt loss is very predictable in tensioning. To compensate for this predictable load loss, extra load is applied in the form of pump pressure A to the first bolts so that they relax down to the required load when pump pressure B is applied to the next bolts. At times, this pressure A being higher than pressure B may not be permitted to be applied for being on safe side of the bolt yield capacity. In this situation, only 100% bolt tensioning is possible unless the required bolt stress can be reduced. If space from one side of flange does not permit, tensioners can be mounted from both sides on alternate bolts. 25% tensioning means 25% tensioners to bolt ratio. If you have 8 bolts on the flange, then you use 2 tensioners. Mark bolts as 1, 2, 3, 4. You are given A pressures to go on 1 and 2 and B pressures to go on 3 and 4. Use our bolt load software to get pressure load values for these configurations on standard flanges.